test, which I'm hoping will be Friday, depending on the weather, guys, you get a point, 10 points for having all the notes down. These are easy points. Do the easy points, so if you don't do super well on a test, you can still have a grade, a passing grade. You guys can do this. Okay, so what we're looking at, these are page 29 notes. So in your binder, I hole punched these, just put them in front of page 29. So that way, I also labeled it, whatever page 29 is. Describing functions and equations, tables, and graphs. Okay, so this is page 29. So in your binder, just put this in before page 29. If you want to staple it to it, I don't care. But that way you know it's easier because you don't have to write all this stuff down. So what we are doing today in this first section, there is no pretest because it's a short section, so everyone needs to be taking these. What we're doing with these is we are switching between equations, tables, and then graphs. And you've done this before. A lot of this is kind of review. But we're switching between graphs and tables and equations, which we've kind of already done. Okay? So what we're going to do on the first couple we are graphing each equation. So as I look at this one, this is y equals 3x. Okay, this is a function. We also know how to graph this using the shortcut, y equals mx plus b. But for today, all we're going to do is just complete this table. My input is my x values. The input is also the domain. So when I refer to the x values, that is my domain. The y values are the range. So x, it goes alphabetical order. Domain comes before r, x comes before y. So domain is x, range is y. So all you do, if you know your x value is -1, how do I find the y value? Plug it in. 3 times -1, -3. Okay, let's plug in 0. 3 times 0, 0. So this is exactly like we did a couple units ago. Plug in 1. 3 times 1, 3. Plug in 2. 2 times 3, 6. Plug in 4. 3 times 4, 12. Devontae, get this down for me, please. Now, okay, so this is nothing new. This is just kind of, the wording of it is just kind of different. So now we're going to graph this. We just have ordered pairs. -1, -3. 0, 0. 1, 3. 2, 6. 4, 12. Okay? This is nothing new. We're just kind of treating it as a function. Yes?
Are these all going to be like straight lines?
No. Okay?
Hooray.
So you have it graphed, which is nothing new. And then it wants to tell whether the equation is linear or nonlinear. There's a couple ways to tell. First of all, the easiest way, look at the graph. How can I tell whether this graph is linear or nonlinear? Do not overthink this.
If it passes the...
No, that's a function or not.
If it's just like,
Is this linear or nonlinear? Yeah, linear. It makes a line. If it makes a line, it is linear. That's a function which is, these will work, but yeah, linear. Does it make a line? If it makes a line, it is linear. Okay? Now, you can also tell by looking at the table. If your x's and y's have a same difference, if they are consistent, then it is linear. So if you look at your x values, how do I go from -1 to 0? Add 1. How do I go from 0 to 1? 1 to 2? 2 to 4? Add 2. So even though there's a break here, let's look at my y values. -3 to 0. Guys, up in the front, please. We're taking like 15 minutes. You can stay with me. -3 to 0. Add 3. 0 to 3. 3 to 6. Now 6 to 12. Add 6. Now, even though the last one is not consistent, we can follow the pattern. Because what number should I have between 2 and 4? 3. 6 and 12 is 9, so it's still consistent. So if you're adding or subtracting the same thing with your x's and y's, then it is linear as well. Guys in the front, I know you're not talking, but you're also not paying attention super well. I know, but you're also looking at each other. I'm not taking many notes, so when I do, I want you paying attention, please. Okay, now as I look at number 2, I have my input and my output. So let's go ahead and fill this in. Okay, as I look at this, I have an x value of -2. If I plug that in, what will my y value be?
Plus what?
Negative 2 squared is what? 4 plus 1? 5. Now when you square a negative, it always turns it positive. So negative 2 squared is 4. 4 plus 1 is 5. Let's do negative 1. Negative 1 squared? Negative 1 squared? 1. Because it's squaring is multiplying by itself. So negative 1 times negative 1. 1 plus 1 is 2. You're good. Yeah. Okay, plug in 0. 1. 0 squared plus 1 is 1. Plug in 1. 2. 1 plus 1. Plug in 2. 2 squared, 4 plus 1 is 5. Now, as I look at this, just look at your table. Is this going to be linear? No. Because this is minus 3, minus 1, plus 1, plus 3. It's not consistent. So I can already know that it's not going to be linear. Let's graph this. Negative 2, 5, between 4 and 6. Negative 1, 2. 0, 1, between 0 and 2. 1, 2, and 2, 5. If I connect the dots, this is not linear. It does not create a line. It actually creates a what? Parabola. This is nonlinear because it does not create a line. It is actually called what? What type of equation will give me a parabola? Starts with the Q. Quadratic. This is actually quadratic, not linear. Okay? Which we'll talk about. You don't need to put quadratic, but just FYI.
Are we going to ever have to put quadratic down?
Not today, but in a couple units we'll talk about quadratics, yes. Okay. Any questions? That's where you got lost, not in this class. Okay, let's look at the next couple, 3, 4, and 5. Tell whether each equation can be written in the form y equals mx plus b. What's that form called? Slope-intercepts. Just FYI, we talked about it in Unit 2, or whatever unit we were in. I forget, the numberings are off. So, tell me, can I write it in slope-intercept form? If I can, write the equation as y in y equals mx plus b form. Okay, let's look at 3. Can I write 3 in that form?
Yes.
Can I?
No.
Y equals mx plus b.
Why not? It doesn't work.
Why not?
Because the x is minus.
No.
Listen, it doesn't follow the x is squared.
X is squared. If x is squared, we know it's not linear. You will get a quadratic. So if x is squared, it is no. Because x squared is not a line, it is a parabola. So anytime you have an x squared, it is no. Okay, let's look at 4. Do I see x squared? No, so I'm thinking this is linear. Can I write it in that form? Yes, how do I write it in that form?
Y equals x plus 4.
Yeah, equals x plus 4. So like I said, this is kind of review, but just kind of looking at it from a different angle. And then 5. X is not squared. Can I write it in y equals mx plus b form? Which will be y equals negative 2x plus 3. Okay? So kind of review, just kind of looking over this stuff. And then let's look at the last example, and I'll give you some time to work on the homework. The amount of water in a tank being filled is represented by the equation y equals 20x, where y is the number of gallons in the tank after x minutes. Guys, I literally told you 10 minutes ago. I'm not talking to you. I'm talking to Austin, who was turned over. Seriously. I'm really not thank you. Yes, paying attention for 15 minutes is very doable. Thank you. Okay, complete the table of values for this situation. So same idea, we're just kind of representing it as a story problem. My equation is y equals 20x. So if my time is 0, if my x value is 0, y will be what? 0. Plug it in. 20 times 0. 0, 0. If my x value is 1, value is 2.
40.
So you see a pattern of this. Now, for the fourth one, Your y value is 60. What will my x value be? 3. So like I said, if it's linear, it has a pattern. If I plug in 4, 20 times 4 is 80. Okay? So as you go through this, you can see a pattern, and you should be able to fill it in. Okay? Now, since I see a pattern, what do I know before I graph it? What do I know this graph will give? It's going to be linear. My x values are add 1, add 1, add 1, add 1. My y values are what? Add 20, add 20, add 20, add 20. How could I also tell it was linear? Not by looking at the table.
As it follows, the y equals mx plus
Yep, it looks like y equals mx plus b. My y-intercept, what's my b value?
That's 0.
0 is plus 0. Okay, guys. So it follows that y equals mx plus b. There's no x squared, so I'm thinking this is linear. Let's sketch a line. Okay, 0, 0, 120, 240, 360, and 480. So we do get a line when I graph this. Okay. The next question, question 8. Use your graph to predict the amount of water in the tank after 6 minutes. Look at your graph. Okay, if I look at 6 minutes will be right here. What do you think if it follows the same pattern? Well, how many gallons do you think I will have? 120. So after 6 minutes, it looks like I will have 120 gallons. So 120 gallons. Okay. And then 9. Explain how you know whether the relationship between x and y is linear or nonlinear. There's a couple ways. Give me all the ways. How do I know the relationship between x and y is linear or nonlinear? More specific. Because I want you to. Okay, graph is a line. That would be one acceptable answer. Okay, one would be graph is a line. The equation looks like y equals mx plus b, like we talked about. Okay, x and y are not squared, so it follows that pattern. And then the last thing, so you can tell it's linear by the graph, you make a line. You can tell it's linear by the equation, if it looks like y equals mx plus b, x and y are not squared or to the third, they're both to the first. The third way, by looking at the table, how do I tell by looking at a table if it's linear?
a pattern.
Table has a pattern. And a little more specific, table has a pattern. I am adding or subtracting the same number. So I'm adding 3 each time, or I'm subtracting 2 each time, or whatever. So we kind of talked about this stuff, but we're just kind of just taking a step back and saying, how do I tell whether a graph is linear? How do I tell whether my equation is linear? And using that stuff. Okay, any questions on that? Okay, that's it for the notes. Let me give you the homework packet.
Good job.